Hey, hi all, very good evening. Thanks for joining with me. Hope you're all doing good. Welcome to day 3 of Python 30-day sessions. So in the last two sessions, we had a discussion on history of Python and introduction to Python and Jupyter Notebook basics. In the last session, we had a discussion on operators. We had a discussion on operators, data types, and then operators. We had a discussion arithmetic operators, assignment operators, relationship operators, logical operators, membership operators, and identity operators, and bitwise operators. These are operators we have in Python. In the last session, we had a discussion on what are the operators we have and what is an operator. And these all things we had a discussion in the last session. So welcome to day 3 session of Python 30 days course. In the last two sessions, we had a discussion on what Python is, history of Python, and the variables, keywords, identifiers, and data types, and operators. The operators we started learning. In these operators, the very first one is arithmetic operators, and the second one assignment operators, and then relationship operators, comparison operators, logical operators, membership operators, identity operators, bitwise operators we have. There are around 7 types of operators we have in Python. When comes to arithmetic operators, addition, subtraction, multiplication, division, floor division, modulus, exponentation, these are the arithmetic operators we have. So you can see, and yesterday we had a discussion on all those arithmetic operators. In this evening, the very first topic for this evening is assignment operators. The first topic for this evening, assignment operators. What are the assignment operators and how do we use assignment operators? Assignment operators are used to assign values. Assignment operators. Assignment operators are used to assign values. Assign values to variables. Assignment operators are used to assign values to variables, meaning that simple. For example, if you take a is equal to 10, so equal to is an operator, is equal to is an operator. So 10 is a value. 10 is a value. A is a variable name. Name of a variable, simply A is a variable, which is holding a value 10. So 10 is assigned to a variable A by using an operator. For example, data is equal to, I'm writing 20. 20 is assigned to a name. 20 is assigned to a name data by using equal to operator so that it becomes a variable. So equal to is used to assign values to the variables. Equal to is assigned used to assign values to the variables. Okay. So we do have only one assignment operator, that is equal to. There is only one assignment operator, that is equal to. The symbol is that equal to. So for example, a equal to 23, this is assignment operator. By using assignment operator, we are assigning a value. So b equal to something 78, we are using it to assign a value. So data is equal to something like Python. So equal to is used to assign a value to a variable data. Okay. Like this, we can use assignment operator to assign values, and compound assignment also we can do with assignment operators, meaning that, for example, a equal to 10. My question is add 20, add 20 to variable a, so that we do like a is equal to a plus 20, so that 10 plus 20 output is 30, right? The same thing The same thing, same code line can be written as the same code line can be written as a plus is equal to 20. A plus is equal to 20, meaning that the meaning of this one is a is equal to a plus 20. If I write a plus is equal to 10, meaning that a is equal to a plus 10. If I write a minus is equal to a minus is equal to 3, if I write, meaning that a is equal to a minus 3. So this is called compound assignments. We can do compound assignment also. You can do compound assignment also. So meaning that, for example, a equal to have taken 10, a equal to have taken 10. I have taken a is equal to 10. So a plus is equal to a plus is equal to 20, meaning that a is equal to a plus 10. A is equal to a plus 10. So a value will be 30 now. So if you want to subtract something, if you want to subtract something, so you can write like a minus is equal to, I want to subtract 10, meaning that a is equal to a minus a minus 10. So that 30 minus 10, that is 20. 30 minus 10, that is 20. Like this, you can use assignment operator as a compound assignment. So, and next one, we can use for all the arithmetic operators into equal to a is 20, 20 into 3, meaning that a is equal to a into 3, a is equal to a into 3. So what happens, 20 into 3, that is 60, a is 60 now. Like this, we can use this operator. Like this, we can use this assignment operator for compound assignments. Okay. So the next operator is relationship operators, relationship or comparison operators in Python. The very next operators, relationship or comparison operators, relationship or comparison operators, relationship or comparison operators. So here we do have in relationship and comparison operators, we have greater than, we know the symbol of greater than, this is greater than, and we do have less than. So this is the symbol for less than, greater than, less than, and greater than or equal to, greater than or equal to. So greater than or equal to, this is, so less than or equal to, so this is less than or equal to, and then equal to, checking for equality, equal to, so checking for equality, double equal to, and then not equal to, not equal to, checking for not equality. So no, this is not equal to symbol. These are the operators available, relationship or comparison operators. These are used to compare relationship between, these are used to, these are used to compare two variables or values. And these operators returns true or false. These operators returns true or false, either true or simply false. These operators returns true or false only. So let me write 10 greater than 5. It's true, right? It returns true. If I write 10 is greater than 20, it returns false. The greater than operator we can use like this. For example, a equal to 20, b equal to 30. Just you can rise, just you can write a greater than or else b greater than a if you write. then it returns true because A is greater than B. To compare two values or variables, we use comparison operators or relationship operators. The next one, greater than, less than or equal to, or less than. So let me show you less than. We know all these, right? So 10 is less than 20, that is true. So less than or equal to, so less than or equal to 10, less than or equal to 10. First is checks whether 10 is less than 10. So that is not true. Then equal to, it checks. Then 10 equal to 10, that returns true. And greater than or equal to, greater than or equal to, just you can write 10 is greater than or equal to 10, it returns true because 10 is greater than 10, that is false. Then checking for equality, those are equal, then it returns true. Okay. In such a way, those will be used. Okay. And then less than, greater than equal to, less than equal to, and equal to. Just you write equal to. Just 10 equal to 10, if you write, it returns true. 20 equal to 10, if I write, it returns false. Okay. Then not equal to, not equal to meaning that simply it returns true if two values are not equal. 10 not equal to 20, if I write, the statement is true. It returns true. 10 not equal to 10, it returns false because 10 is equal to 10. So these are the comparison operators we do have in Python. So the next one, logical operators, very important one. The logical operators. Let us discuss about logical operators. What are the logical operators? The first one is logical AND. The symbol is AND only with the keyword. Logical OR. We use a keyword OR for logical OR. Logical NOT. We use NOT. So let me explain you these logical operators, how these logical operators works. So let me explain you the logical operators. Just we are done with assignment operators and comparison operators. So now we'll see logical operators. What are the logical operators? There are three logical operators. What first one is AND operator, logical AND, logical OR, and logical NOT. Logical AND, logical OR, logical NOT. Let me tell you, logical operators are used to combine two statements. These used to combine two statements. Logical operators used to combine two statements. You can ask me, Satya, what do you mean by two statements? Here, what is a statement? For example, A greater than B is a statement. Something B less than A is a statement. So like this, to combine two statements, we use logical operators. Logical operators are used to combine two statements. For example, this is statement 1, this is statement 2. So to combine them, we use logical operators. Logical operators mainly used to combine two statements. Okay. So how do we use them and how to write them? Let us see. So logical AND, the very first one, logical AND. It returns true. It returns true if two statements are true. It returns true if two statements are true. It returns true if two statements are true. false otherwise. It returns false otherwise. It returns true if both statements are true. Meaning that, for example, so let me give you a truth table for it. Let me give you a truth table for it so that you can easily understand. Logical operators. And one more I need to add. Statement 1, statement 2, and the result. So here, this is statement 1. Assume that statement 1. And this is statement 2. And this is result. So statement 1 is true. If, for example, this logical AND, I'm talking about logical AND, the truth table for logical AND. The truth table for logical AND. So the first statement is true. Second statement is true. If both statements are true, output is true. My statement, you can see, it returns true if two statements are true, false otherwise. So the first statement is true and second statement is false, then output is false only. And third combination, there are two statements so that we can have four combinations. Okay, two statements and there are four combinations we can have. So the first statement is false. First statement is false. Second statement is true. The output is false. And third one, last one, the first statement is false. Second statement is false. Output is false. There is only one condition where we get true. There is only one condition where we get true is true and true, output is true. The logical AND, it returns true if both statements are true. Logical AND returns true if both statements are true. Logical AND returns true if both statements are true. That is the only situation where we get, true. Okay. That's the only condition. So all other conditions, it returns false only. All other conditions, it returns false only. Okay. So that is what logical AND operator. And then logical OR operation, it returns true if one of the statement is true. Logical OR operation, it returns true if one of the statement is true. Meaning that this is logical AND, then logical OR, I'm sorry. Logical OR operation, logical OR. So statement 1, statement 2, and result. I'm talking about logical OR. So logical OR returns true. It returns true if one of the statement is true. If one of the statements is true. Meaning that in two statements, if one statement is true, output is true. So simply true or true, output is true. And true or false, output is true. Because one statement is true, output is true. And then false or true, output is, I'm sorry, false or true, the output is true only. And then final one, false or false, false or false, output is false only. So this is logical OR operation. Logical AND returns true if both statements are true. And logical OR returns true if one of the statement is true. Okay. And logical NOT, the other logical operator, logical NOT. Logical NOT returns reverse of a result. It returns reverse of a result. It returns reverse of a result. Meaning that not of, if I write not of true, output is false. And not of false, output is true. It returns reverse of a result. Okay. So let us write here. The very first one, logical AND operator. Logical AND. It returns true if it returns true if both statements are true. False otherwise. It returns true if both statements are true, false otherwise. Okay. So the truth table, I'm writing the truth table also so that you can remember for the long time. Statement 1, statement 2, result. First statement is true, second statement is true, output is true. And first statement is true, second statement is false, output is false. And false and true, output is false. And finally, false and false, output is false. So this is a truth table for logical AND operation. Truth table for logical AND. So let us take two statements. Let us write A equal to 34, B equal to 45. I have taken two variables. Now I'll write two statements. A is less than B. A is less than B. AND operator. AND operator. A is less than 50 or A is less than 100. So both statements are true. A is less than B. 34 is less than 45. That is true. And 34 is less than 100. That is also true. True and true, it returns true. Output is true. If both statements are true, then only it returns true. There is only one case where we get true is both statements should be true. Okay. That is what simply logical AND operation is. Logical AND is it returns true if both statements are true. Okay. And the other one, second case, true and false. A less than B is true and 12 is greater than 20. So it is true or and false case. True and false. True and false, it returns false only. So first case true, true and true, that is true. This is true. Second one false. And third one false and true. A is greater than 50 is a false statement and A is less than 50 is a true statement. False and true, it returns false. And false and false, A greater than 50 and B is greater than 100. It is false and false. It returns false. So the four combinations you can see, but there is only one possible case to get true is both statements should be true. The next one, logical OR operation. or operator, logical or. Logical or, it returns true if it returns true if one of the statements is true. It returns true if one of the statements is true. False otherwise. So the truth table is let me write the truth table. True, true, and finally false. So I'll write operator also so that you can easily understand. So true, true or false, false or true. You can check true or true, output is true. Either one statement is true, output is true. So let me write, either one statement is true, output is true. Let me write that. So true or true. So A is greater than, A is less than, I'll be writing A is less than 50 and B is less than 50. This is true. Sorry, not AND operator, not AND operator. It is OR operator. One statement is true, output is true. True or true, it returns true. True or true, it returns true. And the second one, true, true or false statement, I'll be writing B is greater than 78. That is a false statement. True or false, it returns true. And then third one, false or true. False statement A is greater than 50 is a false statement, or false or true. True statement A is less than 50 is a true statement. False or true, it returns true. The last one, false or false. The last one, false or false. So A is greater than 50 is a false statement, or A is greater than 45 is also a false statement. False or false, output is false. The four combinations we have checked. The next one, logical not operation. The next one is logical not. What is logical not? It returns reverse of a result. It returns reverse of a result. For example, 10 is less than 20 is a true operation, right? 10 is less than 20 is a true. If I write not of 10 less than 20, then returns false. True returns false, false returns true. So not of false statement, if you write 10 is greater than 20, false statement returns true. Those are logical operators. Those are logical operators we can see. Okay. So logical and, logical or, logical not. There are three logical operators: logical and, logical or, logical not. Okay. Then after this one, after logical operators, we have membership operators. Membership operators, we'll see what are the membership operators. We'll see now. Membership operators. What are the membership operators in Python? Let us see in and not in. So let me put a heading. Membership operators. So there are two membership operators in and not in. In and not in. Two membership operators. Those checks whether an item is a part of a sequence or not. Membership operators checks whether an item is a part of a sequence or not. Very simple. It checks whether an item is a part of a sequence or not. Okay. So what are these membership operators? Let us try to understand. So membership operators used to check whether a value exists inside a sequence or a collection, like a list, tuple, string, set, or dictionary. So let me write simple description so that you can remember. Membership operators are used to check whether a value exists, a value or an item, a value exists inside a sequence or collection, like list, tuple, set, dictionary, and membership operators are used to check whether a value exists inside a sequence or not. Meaning that, for example, the very first one in operator, what is this in operator does? It returns true. In operator returns true if the value is present in the sequence. It returns true if the value present in the sequence. It returns true if the value present in the sequence. Okay. For example, if I write A equal to programming, I'll be writing a character P. I'm checking character P in A. So that is true. There is a character P in a sequence, a character P in a sequence A. So it returns true. Okay. Like that. For example, if I write A in A, it returns true. Or else I'll take a list of items. I'll take 12, 34, 56, 78. That is my list. 34 in L, it returns true. Okay. So like this, if you want to check whether an item is a part of a sequence or not, we use this. Whether an item is a part of a sequence or not, just we use in and not in operators. So A is this. If I write X not in A, that's true. X is not there in A. A is simply programming. X is not there in A. So it returns true. For example, if you write text is equal to Python is good programming language. Python is good programming language is my string. So if I write something like Python in text, if I write, it returns true. If I write Java in text, it returns false because there is no Java. For example, if I write good in text, good is there in my text variable. Good in there in my text variable. And I'll write something like Java not in text. It returns true because Java is not there in that particular text. That is how we can use Membership operators in Python. Membership operators in Python. There are two operators, in and not in. Okay. So the next one, identity operators in Python. Very important one and tricky one. Identity operators in Python. Identity operators. What are these identity operators? Identity meaning that checking the memory location. If two objects or two variables refers to the same object in a memory, so identity operators are used to check whether two variables refers to the same object in a memory, not just equal values. If though two values are same, their locations are not same. These identity operators are used to check whether two variables refers to the same object in a memory, not just equal values. Okay. So let me write simple statement. Identity operators are used to check. Identity operators are used to check whether identity operators are used to check whether two variables two variables refer two variables refer to the same object in memory. Same object in memory. Identity operators are used to check whether two variables refer to the same object in memory. The two identity operators we do have. The first one is. The first one is not. Is and is not. There are two identity operators. So the very first one is operator. What it does, simply it returns true. It returns true if both variables point point to the same object. Point to the same object meaning that same memory location. If two It returns true if both variables point to the same object, meaning that same memory location. In a memory, if two variables have a same memory location, then it returns true. So this is a simple exact opposite. Is not operator, it returns true. It returns true if variables both variables point to different objects. That means different memory locations. It returns true if both variables point to the different objects. So let us see. For example, A equal to 10, B equal to 10. I want to check location of A, memory location of A. ID is a function. ID is a function to check memory location. ID is a function to check memory location. ID of A, it returns memory location. ID of B, it returns memory location. Here, A is equal to 10, B is equal to 10. In memory, those are pointing to a same memory location. Then A is B, it returns true because A and B locating to or pointing to same object, meaning that same memory location. For example, A equal to 3, 4, 5, 6, B is equal to 3, 4, 5, 6. If you check the locations ID of A, comma ID of B, you see those are two different locations. Though values are same, the locations are not same. Though values are same, their memory locations are not same. So that if I write A is B, it returns false. It returns false if you write A is B because their memory locations are not same. Because their memory locations are not really same. you can ask me, Satya, then here in this case, A equal to 10, B equal to 10, pointing to same memory. Then A equal to 3, 4, 5, 6, B is equal to 3, 4, 5, 6, why it is not pointing to same memory? So for example, A equal to 124, B is equal to 124. Then if you write ID of A, comma ID of B, it returns same memory location. You see, it returns same memory location, meaning that there is a concept called integer catching or integer interning. Integer catching or integer interning. Integer catching or integer interning, meaning that small integers minus 5 to small integers minus 5 to 256. Small integers minus 5 to 256 will share same memory location if both values are same. If both values are same and that values are in the range of small integers minus 5 to 256, then those will be sharing same memory location. So A equal to, you see, 256, B is equal to 256, ID of A, comma ID of B, if you write, the memory location is same. You see A equal to 278, B is equal to 278, ID of A, comma ID of B, if you check, the memory locations are different. The small integers minus 5 to 256, and if two variables have same value, that value within the range minus 5 to 256, then the memory will be shared. That concept is called integer interning or integer catching. Okay, integer interning or integer catching. So here A is not B. Yes, it returns true because A and B are not same memory locations. Though values are same, the memory locations are not same. Though values are same, memory locations are not same. That's why A is not B. It returns true. Okay. That is how it works. That is how it works. Identity operators in Python. And the next one, bitwise operators, very important. Let me explain you the bitwise operators. So identity operators are used in optimization techniques where if you want to optimize the memory locations, if you want to uh, optimize your code, optimize your performance of your application, then checking memory locations, if they're pointing to same memory, having only one variable, that reduces your code and as well increase the processing speed. Okay. So bitwise operators. Bitwise operators. What are the bitwise operators? So what are the bitwise operators? There are bitwise operators performs operations on binary data. Bitwise operators, bitwise operators performs operations on binary data. Bitwise operators performs operations on binary data. So there are few bitwise operators we do have. Bitwise end operator. The symbol is this, and bitwise or operator we do have. Bitwise or operator and bitwise not operator also we do have. The negation symbol is a bitwise not, and then bitwise and bitwise or bitwise not, and bitwise XOR operation also we do have. Bitwise XOR, the cap symbol, bitwise XOR, and then bitwise left shift, bitwise right shift, bitwise right shift, and bitwise left shift. These are the bitwise operators we do have in Python. So to understand this, how to see a binary number, for example, a equal to 10 we have, binary of a, this is 0, see here, this is a binary value of a. For example, a equal to 4, b binary number of a is 0100. That is a binary number. So there is a famous coding technique. There is a famous coding technique, 8241 coding technique, 8421. 8421 coding technique is there to see your binary values. Let me show you that. 8421 coding technique. So for 0, the binary value is 0, 0, 0, and 0. For 1, in one location 1, the remaining zeros. For 2, location 1, the remaining zeros. Okay. So for 3, 3 means 2 plus 1, 2 plus 1. 2 location 1, 1 location 1, remaining zeros. And if it is 4, 4 location 1, the remaining zeros. Okay. And 5, 4 plus 1, 5, 4 plus 1, 5, 4 location 1, 1 location 1, the remaining zeros. And if it is 6, 4 plus 2, 4 location 1, 2 location 1, remaining zeros. And if it is 7, 4 plus 2 plus 1, that is 7. 4 location 1, 2 location 1, 1 location, 4 plus 2 plus 1, that is 7, 0. And if it is 8, 8 location 1, remaining zeros. And if it is 9, so 8 location and 1 location. So these are the binary values of 0 to 9. These are the binary values of 0 to 9. For example, a equal to 3 and b equal to 4. You will talk about bitwise AND operator. The very first one, bitwise AND operator. We'll talk about bitwise AND. The symbol is this symbol, A and B, meaning that 3 and 4. What is the value of 3? What is the value of 3? 0, 0, 1, 1 is a value of 3, right? 0, 0, 1, 0, 3. So what is the value of 4? 0, 0, 0, 1, 0, 0, 0, 1, 0, 0.
011, sir.
End
Yeah.
operation, both are true, output is true. End operation, both are true, output is true. See here, 0 and 0, false and false, output is false only. 1 and 0, true and false, output is true and false, output is false only. I'm sorry. True and false, output is false. And end operation, 0 and 1, 0. And 0 and 0, this is 0. As AKS is 0, 1, 1. 3 and 4, I'm sorry. I'm sorry. 3 value is 0, 1, 1. 3 is 1, 1, right? Yeah, thanks. 0, 0, 1, 1. So 1 and 0, 0. 1 and 0, 0. 0 and 1, 0. 0 and 0, 0. So 3 values this 3 and 4. Simply 0, 0, 1, 1. The 4 values 0, 1, 0, 0. Then logical AND, meaning that true and true, output is true. True means 1. 1 and 1, output is 1. All the remaining zeros. 1 and 0, 0. 1 and 0, 0. 0 and 1, 0. 0 and 0, 0. Output is 0. That is bitwise AND. For example, 5 bitwise AND of 6. What is the value of 5? 0, 1, 0, 1. What is the value of 6? 0, 1, 1, 0. 0, 0, 1, 0. What is the value of it? 0, 1, 0, 0. 4. Output is 4. 5 and 6, output is 4. That is what bitwise AND is. That is what bitwise AND operation. So for example, A equal to 3, B equal to 4, A and B, that is 0. You can check binary number, binary of A, comma, binary of B. These are the binary ones, 0011, 0100. Then A and B, that returns 0. Okay. And 4 and 5, 4 bitwise AND of 5, it returns 4. Okay. Binary of 4, comma, binary of 5, we can check 0100, 0101. Okay. This is how it works. This is how it works. So by bitwise AND operation, this is bitwise AND operation. This is bitwise AND operation. Now bitwise OR operation, we'll see. Bitwise OR operation. So for example, 4 or symbol, 4 or 5. What is the value of 4? 0100. This is value of 4. 5 value 0110 is, sorry. The 5 value is 0101. 8421. So 4 value is 0100 and 4 plus 1, 5. 4 or 5. Or operation I'm doing. See, one output is true, output one bit is true, output is true. One bit is true. Among one bit is true, output is true. 000, 1 and 1, 1. 1 or 1, 1. 0 or 0, 0. Output is 0101. Output is 5. 4 or 5. Something 3 or 4, if I write, value of 3, 0011. Value of 4, 0100. So 1, 1 and 1, 0. One bit is true, output is true. So the output is 7. 3 or 4, 3 or 4. You see, 3 or 4, 3 or symbol 4. Output is 7. You got it right? 3 or 4, output is 7. That is what bitwise OR operation. That is what bitwise OR operation. Bitwise OR returns 1 if one of the bit is true on binary data. Okay. So that is how bitwise and bitwise OR operation works. Bitwise and bitwise OR operations. And now bitwise NOT operation, a bit tricky. The bitwise NOT operation, very simple. For example, A equal to 10, output should be minus of, output should be minus of A plus 1. Minus of A plus 1, that is minus 11, right? So negation of, you write negation of A, that is minus 11. See, A is equal to 10, bitwise not is negation. Negation of A, that is minus 11. Yeah, Rajesh, logical works on normal numbers, bitwise works on binary data. Logical operators works on two statements. Logical operators is to combine two statements, A greater than B and B greater than C, something like two statements. But here, two bits. Bitwise operators working on two bits. The logical operators working on combining two statements. Statement outputs 0 and 1. Output of a statements. Those are output of a statements here, only binary values. Okay. Then the other one. So how this works? Binary negation of this value, how it works, negation of this, how it works. Let me explain you. For example, a equal to 3. Negation of 3 meaning that actual binary value of 3 is 0, 0, 1, 1. The negation means one's complement. 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 So one's complement means 0 becomes 1, 0 becomes 1, 1 becomes 0, 0 becomes 1 becomes 0. What is the value of it actually? 8 plus 4, 8 plus 4, 8, 4, 2, 1 coding technique, right? So this is a value. This is a value. And negation of a meaning that negation means complement. Complement means one's complement. 0 becomes 1, 1 becomes 0, 0 becomes 1, 0 becomes 1, 1 becomes 0. That is what one's complement is. Then output should be 12. Output should be 12. But we are not getting that 12. For example, negation of 3, if we write output is -4. We should get actually 12. How it is getting minus, how it is getting 12? Let me explain you. Here a equal to 3. The value is 0, 0, 1, 1. There will be a parity bit. There will be a signed bit. Positive numbers have 0. Negative numbers have 1. This is a positive number, so it have a signed bit here. Negation of a, this 0 becomes 1's complement. 0 becomes 1, 0 becomes 1, 1 becomes 0, 1 becomes 0, and this becomes 1. 1 means negative. So -12, the output should be -12. Actual output of negation of a should be -12, but we are getting -4. How? Because negative values are not gonna store in memory directly. Negative values are stored as a 2's complement data. Negative values are stored as a 2's complement data. Negative values are stored as a 2's complement data. Negative values are stored as a 2's complement data. So 2's complement of the result. So this is the result. This is the result. What is 1's complement? 1, 1, 1, 1, 0, 0 is the result. What is the 1's complement of it? What is the 1's complement? 0, 0, 1, 1. What is the 2's complement of it? 2's complement means adding 1, adding 1, adding 1. 2's complement means adding 1. 1 and 1 addition operation plus addition operation 1 and 1, 0 carry 1. 1 and 1, 0 carry 1. 0 and 1, 1. And this is 0. 0, 1, 0, 0 is an output. 0, 1, 0, 0. 8, 4, 2, 1, 0, 1, 0, 0. Output is then 0, 1, 0, 0 is a 4, right? Output is 4. But here a negative symbol is there. That is parity, signed bit 1 is there. So negative of this one, then -4, -4. Very simple. Actual value is something like a is equal to 3. 0, 0, 1, 1 is a 3 value. So negation of a means that complement 1, 1, 0, 0. So the output should be 12. But here there is a signed bit 0. When you complement it, that becomes 1. The output should be -12. The output should be -12. But in your computers, negative values will be stored as 2's complement data. 2's complement data. Result is this one. Result is this one. What is 1's complement of the result? 1 becomes 0, 1 becomes 0, 0 becomes 1, 0 becomes 1. 2's complement meaning that adding 1. While you're adding 1 plus 1, 0, carry is 1. 1 plus 1, 0, carry is 1. 0 plus 1, 1. And 0 plus here 0 basically 0. The value is 4. The value is 4. Already negative sign is there. -4 is a output. That is how this bitwise not operation is going to be done. That is how bitwise not operation. That is how bitwise, a tricky one, but very simple. Negative numbers will not be stored directly. Negative numbers will not be stored directly. Negative numbers will be stored as 2's complement data. Negative numbers are stored as a 2's complement data. So the result of a 2's complement of a result. 2's complement of a result. Okay. So result is minus 12. It is a minus number, negative number, right? That is a negative number. So negative numbers directly will not be stored. So that 2's complement of negative number. Very simple. This is the result. 1's complement is 0, 0, 1, 1. 2's complement is adding plus 1. 1, 1, 0, carry 1. 1, 1, 0, carry 1. 0, 1, 1, 0, 0, 0. Okay. That is how it works. Okay. So these are the bitwise operators. We do have other bitwise operators also, like bitwise XOR and bitwise XOR we have, and bitwise left shift and right shift also we do have. We can discuss those in tomorrow session. That's all from my end today for this evening. In tomorrow session, we'll discuss the remaining operators. Sure, Rajesh. The remaining operators will discuss the remaining bitwise XOR, bitwise left shift, bitwise right shift. And then in tomorrow, day 4 session, we will be discussing strings concepts in Python, which is very important. Please do join me tomorrow session. We'll be discussing strings concepts along with two other operators on bitwise. Okay. That's all from my end today. Thank you all. Have a great rest of your day. See you tomorrow at 6 o'clock. Join me with join with me day 4 session tomorrow. We'll be discussing strings concepts. Thank you. And if you like this session, please say yes or thank you in your chat box in your YouTube. Thank you all. Have a great rest of your day.